Hi my friends, the other day I saw an interesting animation on YouTube. Noticing that problems of instability in operation may occur, I decided to make a study to discuss it with you. Here is the animation as I saw it on YouTube. We start by creating the assembly. Place the main part is the guide. We place it here. There is a plane which I don't want to be present, and this is not fixed in space, so I apply constraint to place this face on the face XY of the assembly. Apply. Then this plane over this one, apply, and the center point and this plane of the assembly. Okay, now I cannot move this part, of course. Next are the other parts. All of them are on my site. You can download them to create the same assembly. 1, 2 axles, a crank, the key, active arm, and the shaft. We place with insert the shaft on this face, apply, then also insert for placing the active arm here, apply. Now I want to see the key. Where is the key? I rotate the axle, and now I see the key. For the moment I make this not visible. Yes. Then I apply constraint. I look for the key, this face, on this face, apply. This axis over this axis, apply, and the other on the other axis. Okay. Now I make visible the active arm. Visibility. I apply again insert to place the crank over the active arm here, apply. I forgot the slider, so place slider. I constrain it with this face to be in contact with this. Apply. Then the slider has a symmetry plane which must be placed over the same plane of the guide. Apply. Cancel. 1 degree of freedom is here. Then I apply insert for this circle and this to place them one over the other. Now if I rotate the active arm, the movement is possible. I can rotate this. Oh, as you see, I didn't place a constraint between the key and the arm. I'll rotate back this to see the key. I see the key and then constrain this face with the face of the channel inside this. Okay, now I can rotate very well this main shaft and I obtain movement. You see, these axles are not necessary, but we place them to have a full actual mechanism. Constrain, insert, aligned this circle with this, apply, and this one with this one. Okay, F6. Now we have a replica of the mechanism in the movie. Good. Now I apply a procedure. Firstly, option color forest, you see colors, forest, to have another background because I like this one. Next, to obtain a good presentation, please take a look at my tutorial Inventor number 160 at the minute 45 and 50 seconds for a procedure to obtain another presentation which will be the next frame. Now it looks better, isn't it? Look at the details. You see something very realistic. Okay, now I want to place the active arm on horizontal to apply drive in order to obtain movement, rotation, automatic rotation. So constrain the plane of the arm the mid-plane of the arm, to be parallel, this first solution, with the face of the guide, this face. Yes, not 0 but 180. This is the start position. Okay. Then, having this constraint, we apply right click, drive, and from 180 let's go to 360 multiplied by 2. Well, start. Let's see what happens. You see, this is not the movement we want to be. Go back. This is the problem when we have an equality, how can I say, in taking to the left or the right for the part which is moved by the system. Again, you see, now is okay, the first, but now it goes also to the right. What means this? Well, this means that the animation is made by using force or something else. My solution for this problem is to use dynamic simulation. When masses are present, the inertia of this body makes it to go further from the half. Yes? Now I repeat the movement. You see what happens. This is kinematics, not dynamics, and this is why there is an instability in the movement. We cannot control this instability to go to the left or to the right. Yes, this is why I use dynamic simulation, but firstly I have to suppress this, because now I cannot move anything here. Yes, this restriction constraint fixes the system, makes it not mobile. So I apply suppress. Yes, now I can rotate, and for you to know, when you want to place it again horizontal, you can apply suppress, unsuppress, actually is unsuppress, and again suppress. Yes, now I am sure that this is horizontal. We move to the dynamic simulation, and if we apply a gravity on this direction, yes, I have a grounded object with an edge on the vertical. I use this to apply gravity. Click here to eliminate the arrow. If I play now, you see no friction was imposed here. If I go to play, the only force or action is due to gravity. Look here. Yes, 1 second was the time limit. Let's apply 10 seconds. And we play again. And we see what happens because of the gravity. And no friction. Infinitely movement because of the force of gravity. Okay. Now I want to apply an imposed motion to this shaft, which will move also the arm. Yes. So I have here standard joints created from the constraints. One of them is this one, another one, another one. Prismatic is the joint between the slider and the guide. Revolution 2 is in this joint. Revolution 3 is what are we interested in, this one. 3 is this, yes, and 4 is the other joint. There are 1, 2, 3 joints with revolution and 1 prismatic for the slider. Automatically created because in the simulation settings we have automatically convert constraints to standard joint. If you eliminate this, you have the message that they will be maintained. These are maintained for you to use them. Cancel. I don't want to do this now. Good. Let's apply imposed motion to this joint. We use properties, right click and properties. DOF1 R is degrees of freedom, only one, or the first one is the last one, and it is a revolution. In this joint, the only movement from 6 is rotation about this axis. Good. This is initial conditions. We don't we are not interested in. This is joint torque. When you apply a torque in this joint, not interested. And this is imposed motion. This is the one we are interested in. Select, enable, then go here and select not input grapher. I don't want to introduce a grapher for the movement, but only a constant value. I apply 40 rotation per minute. This is an unit accepted by Inventor. 40 rotation per minute means another value in degrees per second, which is the default unit. Okay, nothing happens. Now I don't want to see this vectorial presentation, so I click again on the name of the assembly and I start the movement. Are you ready? Okay. Now you see the real movement like in the animation I presented. You can go back to the start point and you can add trace. For instance, I want to see the speed of the slider. This is the point I want to study, and the value is velocity. Do you want to see the trajectory? This is trajectory, this is graphics. Yes, I want to see this. It will be a line, only a line. Apply, and another trajectory. I made here a small hole of 1 millimeter to place the next point for trajectory, this point. The color for the trajectory I want to be yellow. Okay. Apply. Cancel. Home or F6. And now when I start the simulation, I see some things which are trajectory, two trajectories. You see a line and like glasses, another trajectory. Once again, for you, this is the real movement. Good. But I want to see values. We discussed about this in my dynamic simulation tutorials. You can take a look at them. I advise you to take a look there to have more knowledge. And now I go back to the start and I apply output grapher. This is the output grapher. Let me enlarge this, and we have here the traces. The first one is about velocity. I want to see velocity. This is the graph of velocity. If you go anywhere here and apply double click with the left button, you have the position between 0 and 10, which is the duration, yes, the value of this velocity. And you see there is a maximum, there are minimum 0 stationary and maximum 600, which is the speed in millimeters per seconds. Yes, time is 5.5. This is the position, and the speed or velocity is 226. If you click here, you activate the graph, and you can use the arrow keys on your keyboard or keep it pressed to see every moment at a level of tenths of seconds. Yes, good. Now you have all the data for studying better this situation. Another thing about this simulation is presented in my bonus. Yes, look at the bonus to see something very interesting. Now we think how to use this beautiful trajectory in a future project of us. Oh, it seems to be interesting. Yes, it's very simple. Look here. We have two trajectories. One is black, one is yellow. We are focused on this yellow one. This is the second here. Velocity and so on is for the slider, and this is for the midpoint of the crank. This is the point we have selected, and the trajectory is generated by this point. Good. Select trace 2 because you know which one is. Right click, export to sketch. Now I'm asked to select a face parallel with the trajectory if the trajectory is plane or 2D. I select this face of the guide, and now the trajectory is generated as a 2D spline. If the trajectory is 3D, it will be used 3D spline, of course. Good. And where is this? Leave the dynamic simulation, but I want to be at the beginning to leave proper this, and now double click on this part and we see the sketch 8. Yes, copy, new, IPT, sketch, this plane, paste, home. Now we have the 2D spline at our disposition. It depends on what knowledge we have about this kind of curves. Roughly, you can see that every point is fixed. You can select a number of points from the left to the right and to eliminate, delete them. Then you can create a line from this important point to this end point. Then you can split the curve in these 2 points like this. Escape. Then I want to eliminate this, but it seems to be not. I select it, delete, Okay, now we have a curve. This is construction, or I can eliminate it, yes, like this. Finish sketch. We can select any point to create a perpendicular plane on the curve, even if we have some comments. We can use this as a sketch. We project geometry that point, yes, to create a circle with a diameter of 3. Finish sketch, and then sweep. Okay, accept, visibility, F6. You see, we have half of the glasses, the frame of the glasses. So you can create any trajectory using a proper mechanism, and then you can transfer the trajectory in a sketch to be used whatever project you have in your mind. That's all for today. Thanks for watching. Bye bye.